Hello everyone, welcome to a video covering the proof of the law of sines. It may look like I have three different triangles on the screen here, but it's actually the same triangle rotated counterclockwise 2 times. Notice that we are not doing it with a right triangle. The law of sines works with any type of triangle. To derive the law of sines, the first thing we want to do is draw 3 perpendicular lines through this triangle. Each of these lines intersects the opposite angle, like so, and then it forms a right angle at the bottom. Notice that I've labeled all 3 angles of this triangle. The letter I chose for the angle corresponds to the opposite side line. Please excuse my lowercase c. I know it looks like my uppercase c, that's why I made it a slightly brighter color. Next thing we want to do is recall a very simple formula for triangles, that the area of a triangle is 1/2 its base times its height. These orange H lines actually represent the height of the triangle at 3 different orientations. In other words, the area of the triangle is 1/2 a times h, where a is the base of this triangle and h is its height. We also know that the same area is 1/2 b times h, for b base and h2 height. And I'll let you guess the third one. Now that we have the formulas for the areas, now we can start relating h using sine. If we take the sine of c, using SOHCAHTOA, we know that it is opposite over hypotenuse. I could write this as sine of c equals h1 over b. Now multiply both sides by b, and you will get h1 equals b sine of c. I've done the same for the other 2 h values. h2 is c sine of a, and h3 is a sine of b. Keep in mind that these areas are equal, because we are dealing with the same triangle in all 3 scenarios. I've just rotated it different ways. Next, I'm going to take all these h values and plug them into the areas. Here's what that looks like. Notice that there are no more h's, we have it in terms of the side lengths and the angles. Since all 3 areas are the same, I've put equal signs between them. First thing to notice is that we have a 1/2 term on each of these. By multiplying all 3 equations by 2, we can cancel out this 1/2. The next step is really important. We want to divide all 3 equations by a times b times c. When we do this, something really special happens. We get a lot of cancellation. This, in turn, formulates the law of sines. Sine of a over a equals sine of b over b equals sine of c over c. Recall that the small a means the angle, like this, and the large a is a side length, like this. As you can see, the law of sines is mostly a ratio. It's a ratio of the sine of the angles and the respective sides, and this ratio's value is the same for all 3 sides. Here's a quick example using the law of sines. Here I've drawn a 3, 5, 7 triangle, and I've labeled one angle at 120 degrees. Let's say that I want to find angle A here. The first thing you'd want to do is recall that the sine of 120 degrees is root 3 over 2. Next, we can use the law of sines to say that sine of a over 3 is this root 3 over 2 divided by 7, which is sine of b over b. We get that sine of a is root 3 over 3 divided by 14. Using the arc sine, or the inverse sine function, we can find that a is approximately 21.79 degrees. If done correctly, you'd find that angle b is about 38.21 degrees. This is important because all the angles of a triangle have to add up to 180. This is a nice way to check if you've used the law of sines correctly. I hope that makes sense, and thank you very much.